Good evening all of you. Today we are going to see S parameters for series and shunt elements. So here we have the series element as J20 ohms and the shunt element as 30 ohms. Already we have seen two problems on S parameter. Those and all is a very simple problem. But now we are going to deal with series and shunt elements. For this network, two-port network, we have to find S11, S22, S12 and S21. So this is our idea. So this is the given question. To find out S11, what you have to do is, you have to terminate this with Z0. So Z0 you can assume to be 50 ohms. Okay. So that's what is done here. So this is a two-port network. At the port 2, you connect Z0, which is 50 ohms. Now you are viewing from here, which is Z1. So now S11 is equal to gamma 1 is equal to Z1 minus Z0 by Z1 plus Z0. This is the formula. Okay. Now when you view from this, these two are in parallel. That is 50 in parallel with 30. That is 50 into 30 divided by 50 plus 30. That combination equivalent resistance comes in series with J20. That's what is given here. So Z1 is equal to 30 parallel with 50 plus J20. Okay. So after doing 30 parallel with 50, you will be getting 18.75. So that is Z1. Now to find out S11, what you have to do is Z1 minus Z0. Z1 is this 18.75 plus J20 minus Z0. Z0 is the characteristic impedance, this one, which is 50. That is port 2 is terminated with characteristic impedance, which is 50. Then Z1 plus Z0, Z1 plus Z0. After simplifying, converting this into polar form, this is a rectangular form. If you convert that into polar form, you will be getting 37.1020 angle 147.38. And if you convert this into polar form, first initially you add 50 plus 18, 68.75 plus J20. You convert that into polar form, you will be getting 71.6 angle 16.22. So hope you know how to convert rectangular to polar or polar to rectangular with the help of calculator. Okay. So you can divide this 37.1020 by 71.6, and when this angle goes to the numerator, it is subtracted from 147.38. So you will be getting 131.16 as the angle, and if you divide this, you will be getting 0.518 angle 131.16. The next step will be, you convert this into decibels. This itself is the answer, but if you want the answer in decibels, you convert this into decibels. For that, what you have to do is 20 log 0.518 multiplied 20 log 0.518, that will give you minus 5.713 dB. So this is the answer for S11. Now we are going to find out S22. So for S22, what you have to do is, you have to terminate port 1 with Z0, which is 50 ohms, and you are viewing from this point, which is Z2. Okay. For S22, the formula becomes Z2 minus Z0 divided by Z2 plus Z0. So we should carry out the same procedure, but we are viewing from this point. So you will be getting So if you view from here, these two are in series and that combination is in parallel with 30. That is Z2 is equal to 50 plus J20. This gets added up and that combination is in parallel with 30. So parallel with 30. So you know this term multiplied by 30 divided by this term plus 30. That will give you Z2. So I have done the calculation already. I will give you the final answer for that. So Z22, after doing all these things, you will be getting Z2. Okay, now you substitute the value for Z2 in this equation. That is, now S22 will become 0.442 angle 172.87 degree. If you convert this into dB, you will be getting minus 7.092 dB. Angle will be same, 172.87. So the idea is first find out Z2. You substitute here Z2 minus Z0. Z0 is 50 divided by this value plus Z0, that is 50. On simplification only you are getting this. This is in polar form. Now if you convert this into decibels, 20 log, you take 20 log 0.442, you will get this answer, angle won't change. So that is S22. Okay. So the next part will be, we have to find out S21. So the next part will be, we have to find out S21. So for calculating S21, what we have to do, this is terminated with 50 ohms. So next step we have to find out S21. So this is output and one is the input. So output by input. So port 2 is terminated with 50 ohms, which is nothing but the connections that not. And the input side, you are connecting a series impedance which is equal to Z0, which is 50 ohms, and then you have a source which is 2V1 plus, and this voltage is